Hello everyone. The title of this video is Simplify a Complex Rational Expression or a Complex Fraction by using the LCD. Right now, LCD stands for Least Common Denominator. And this is the second video I've put out on simplifying a complex rational expression. The first one was simplifying complex fractions by writing the problem as a division problem. And this is just a second method, right, an alternate method for simplifying complex fractions. And after this video is done, after you've seen me do several examples here, you decide which method you prefer. And you can always use that method to simplify a complex fraction. Right? Both methods work equally well. Right. So every example I'm going to do in this video is taken from a free online textbook at openstacks.org. This book is called Intermediate Algebra 2nd Edition, and I'm in section 7.3 titled Simplify Complex Rational Expressions. And I'll be working on exercises 167 through 186. Alright, so that's 20 examples I'll be doing in this video. And I will have timestamps for each example in the description of the video. So that way, if you don't want to watch, all 20 examples, which of course you don't have to, if you're scrolling through here and say you wanted to look at example exercise 175, well, that would be example 9. Right. Yeah, that'd be a 7 plus 8. Yeah, that'd be example 9. And you just count down and click on the timestamp for example 9 in the description of the video, and you'll see me work on exercise 175. Alright, and example 1 corresponds to 167, right, all the way down to example 20 will correspond to number 186. And also, once I start a new example in the video, I would recommend pausing the video and trying to work on the problem yourself. Try to work it out on your own. And then come back, and play the video and watch me do it. And that way you can compare, your work to my work, if you got it correct or incorrect, just to get a gauge for yourself as to how well you're grasping the material. Okay. So I'm going to get into example 1, which is again exercise 167. And once again, we're asked to simplify each complex fraction or complex rational expression using the LCD. Alright, now actually before I get into this example, I'm going to go back to the textbook and scroll up and show you, go back into the actual heart of the textbook here, and there's a little how-to box. These are the steps I'm going to be following every single example. So first, find the least common denominator, or LCD, of all fractions in the complex rational expression. Now remember, a complex fraction is just a fraction with fractions inside of it. It's fractions within fractions. So there will be a main division bar, right? A main fraction bar, the longest one. And then we'll have, fractions above that bar and fractions below that bar. We're going to find first the LCD of all those fractions. Then I'm going to multiply the numerator and denominator of the entire expression, right? Everything above the main bar is the numerator, everything below the main bar is the denominator. by the LCD, and then finally simplify the final expression, right? And my final result is going to be a simplified single fraction, right, in which the numerator and denominator have no common factor. Right. So I'm going to be following these steps every time, and it is assumed, right, I'm in section 7.3 here, so I'm assuming you'll know the material. You already know the material from sections 7.1 and 7.2. 7.1 was on multiplying and dividing fractions. 7.2 was on adding and subtracting fractions. So I'm assuming that you know how to do those operations already. I'm also assuming that you know how to factor polynomials. All right, this video is not about factoring polynomials. I'm just gonna factor polynomials without explaining how I factored them. All right, and if you'd like to refresh your memory on that stuff, that's all in chapter 6 of this textbook at openstax.org. All right, so finally, now we're getting into example 1. All right, so here we have a complex fraction. Again, hopefully you're seeing why it's considered complex, right? There are fractions within fractions. So there's always going to be, as I mentioned, there's always going to be a main, and I'll put it in quotes here, but there's always going to be a main fraction bar, right? A main division bar in these problems, right? And it's just the longest one. All right, the one in the middle, the longest one, however you want to think about it. And everything above this bar, this will be considered the numerator of the complex fraction. And everything below this bar will be considered the denominator of the complex fraction. All right, so again, I pointed out the steps to you. All right, now the first steps in simplifying the complex fraction using the LCD, the first step is to find the LCD, all right, or the least common multiple of all, I'll call them lesser denominators. Right. All the denominators of the fractions within the fraction. So, the lesser denominators in this example, you have in the numerator, you have 1/3. That fraction has a denominator of 3. Plus 1/8, that fraction has a denominator of 8. And then in the denominator, at the area below the main bar, there's a fraction of 1/4, which has a denominator of 4, and a fraction of 12, which is of 1/12 with a denominator of 12. So here are all the denominators, right, that show up throughout this complex fraction. And hopefully you recall how to find the LCD. You factor each one completely. So one way to do it, I consider this, I guess, the lawn way, would be write 12 as 2 times 2 times 3. 4 is, and then line up any common factors. 4 is 2 times 2, which are common with that 2 and that 2. 8 is 2 times 2 times now another 2, but I'm not going to line it up with the 3. So I'll put times 2 over here to line it up with some other empty space. I'm only lining up things that are in common. And then 3 is simply 3, and I'll line it up with this 3 here. And if you do this, list every individual factor like this, you can state the LCD by just copying the factors that show up in each column. So there's a 2 times 2 times 3 times 2. And there's the LCD, 2 to the third times 3 to the first, or 24. Right, 8 times 3. Now an alternate method would be to write out with powers. 12 is 2 squared times 3. 4 is 2 squared. 8 is 2 to the third. And 3 is, 3 to the first. And then the LCD has the factors that show up to whatever the highest power of that factor is. So the only factors that show up here are 2's and 3's, right? So the LCD is going to have 2 to some power times 3 to some power. And the highest power on any of the 2's is 2 to the third. So 2 to the third will be in the LCD. And the highest power on any of the 3's is 3 to the first in these prime factorizations. And so I'll have 3 to the first in the LCD. All right, get the LCD of 24. Alright, so that was the first step. Second step that I mentioned to you from the text was now I multiply the numerator of the complex fraction and the denominator of the complex fraction, right? So the expression above the main bar and the expression below the main bar by the LCD. Right, so that'll look like this. So here's the complex fraction. Again, we have 1/3 plus 1/8 in the numerator, 1/4 plus 1/12, 1/12 in the denominator, right? And I'm going to multiply the entire expression in the numerator by 24. The LCD, right, or 2 cubed times 3 if you want to write it in factored form, over, and then the same thing in the denominator, multiplying this by 24 as well. Right? It's just like any other fraction. You can't multiply the numerator by 24 and not the denominator, because that'll totally change the value of the expression. What you do to the numerator, you must also multiply the denominator by. Right? That way it's like you're multiplying by 1, right? 24 over 24. And multiplying by 1 doesn't change the value of the expression. Now the whole reason for multiplying by the LCD in the numerator and denominator is so all these denominators, these lesser denominators, cancel, go away, right? So watch what happens here, right? So there are multiple terms, right? So I'm multiplying the 1/3 by 24. I'm also multiplying the 1/8 by 24. That's the numerator. And then in the denominator, right, I'm multiplying the 1/4 by 24 and the 1/12 by 24. And I'll write all this out here, and we'll continue this downward. So this is, numerator is 1/3 times 24 plus 1/8 times 24, and then the denominator is 1/4 times 24 plus 1/12 times 24. And like I said, the whole reason for this is so we get rid of all the smaller denominators, all the denominators of the fractions within the fraction. Right, in the first one here, up top, the first term, 1/3 times 24, 3 goes into 24 8 times. So that's 1 times 8, which is just 8, plus, and then 1/8 times 24, well, 8 goes into 24 3 times, so I'm left with 1 times 3, which is just 3. So the numerator is simply 8 plus 3, or 11. And then I do the same in the denominator. I multiply each fraction, each term of the denominator by the LCD. 1/4 of 24 is 6, and then I have plus And then 1/12 times 24 is 2. And 6 plus 2 is 8. And 11/8, this is as simple as it gets, right? 11 and 8 don't have any common factors. And there you go. There is the final result, right? We're asked to eventually write it as a simplified single fraction, right? The numerator and denominator have no common factors. All right, well now I would like to check, I put a little check mark there, I'm going to check my result. So I'm going to do that with a calculator, all right, pardon me. Now again, this might seem tiny, but I'll say what I'm writing, what I'm typing. I'm going to check to see if this original expression is indeed the same value as this final one. Now the numerator has multiple terms, so I'm going to put that in parentheses. So in parentheses, I'm doing 1/3, right, 1 divided by 3, plus 1/8, and then close parentheses. Then we have divided by, so divided, and then the denominator also has multiple terms, so I'm going to put that in parentheses. And in parentheses in the denominator I have 1/4 plus 1/12, close parentheses, and we get a value of 1.375. 1.375, right? That's 1 3/8, which is actually what 11/8 is, right? The final result, 11/8, 11 divided by 8, is exactly the same value. So the expression in the beginning, the expression at the end, they are indeed the same number, have the same value. All right, and you should be checking your answers, right? You should always be checking or testing your solutions out. Okay, so what I did for this example here, I'm going to do for every example in the rest of the video. You find the least common denominator of all the fractions that are within the fraction, and then multiply everything in the numerator by the LCD, multiply the whole denominator by the LCD. That should get rid of all the smaller denominators, all the lesser denominators, and then simplify the fraction at the end. Simplify if you can. And then, of course, test your solution. Okay, so same steps every time. So example 2 is another example with just some numbers, right? So again, I'm going to write out the lesser denominators. Right, these are the denominators of the fractions within the fraction. Right, this is the main division bar here, the long one. So the numerator is 1/4 plus 1/9. The denominator is 1/6 plus 1/12. So the denominators of the fractions within the fraction are 4, 9, 6, and 12. Right, 4, 9, 6. Anything that appears in a denominator of a fraction. Now 4 is 2 squared, 9 is 3 squared, 6 is 2 times 3, 12 is 2 squared times 3. So the LCD, the only factors that are appearing here are 2 and 3, so it's going to be 2 to some power times 3 to some power. The highest power on any of the 2's is 2 squared. The highest power on any of the 3's is also 3 squared. And 2 squared is 4, 3 squared is 9, this is 36. Right? And again, you might be able to tell what the least common multiple of the denominators is without doing all this, but the least common denominator would be 36. So what I'm going to do, right, is multiply the entire numerator by 36, and then same thing for the denominator, right? Multiply the entire denominator by 36, right? And again, what you multiply the numerator of a fraction by, you must also multiply the denominator of the fraction by. All right, and I'm going to make this a little quicker. Remember, we are distributing, right? There are multiple terms in the numerator, so each term gets multiplied by 36. And the whole point of this, right, the whole point of multiplying by this LCD is to get rid of all the all the smaller denominators. Right? A fourth of 36 is 9. Then you have plus, and then 1/9 times 36 would be 4. So the numerator is 13. 9 plus 4. And then same with the denominator, right? There are multiple terms in the denominator, 1/6 plus 1/12. I multiply each of those by 36. 1/6 times 36, a sixth of 36 is 6. Then we have plus 1/12 times 36 is 3, and 6 plus 3 is 9. And 13 and 9 have no common factors. So that is as simple as that gets. And again, I would go to a calculator or something and check, just see if this original expression, without all the times 36, right, the original expression without all the writing, see if the original expression has the exact same value as 13/9, 13 divided by 9, which would be, 1 4/9, or 1.444444 forever. Okay. So same thing every time. I'm going to find the LCD of the lesser denominators, what I'm calling the lesser denominators, the denominators of the fractions within the fraction. Then multiply the numerator, right, the area, the expression above the big bar, right, the main bar, by the LCD, and do the same with the denominator, multiply that by the LCD. Alright, so the denominators that show up in this complex fraction are 6, which is 2 times 3, 9, which is 3 squared, 18, which is 2 times 9, or 2 times 3 squared, and 3, which is just 3, right? 3 is already prime. So, looking at these factorizations of all the denominators, right, we can very easily now state the LCD. The only factors that show up are 2's and 3's, so the LCD is going to have 2 to some power times 3 to some power. The highest power on any of the 2's is 2 to the first, so it just stays 2. The highest power on any of the 3's is 3 squared. Right, so the LCD is 2 times 9, which is 18. All right. And again, you could have figured this out probably without doing all this factorization. You probably could have said 18 is a common multiple of 6, 9, 3, and 18. But again, I'm just showing you how I'm going to be finding the LCD in every single one of these problems. Alright, so I take the numerator, right, this 5/6 plus 2/9, multiply that by 18, the LCD. Do the same thing with the denominator, right, multiply that by 18. Now, we're distributing, right, there are multiple terms in the numerator, so each one of those, the 5/6 and the 2/9, is multiplied by 18. Now 5/6 times 18, right, 6 goes into 18 3 times, and then you'd have 3 times 5 left over, that'd be 15, plus 2/9 times 18 would be 4, right? 9 goes into 18 twice, and you still have 2 in the numerator. 2 times 2 is 4. So the numerator is 15 plus 4, or 19. Denominator, same thing. There are 2 terms, 7/18 and -1/3. Each one of those gets multiplied by 18. Now 7/18 times 18 would be 7. Then we have minus, and then 1/3 times 18 would be 6. And 7 minus 6 is 1. Now you can leave it as 19 over 1 like this, but dividing by 1 doesn't change any values. So 19 divided by 1 is just simply 19. Alright, so the value, again, get rid of all the writing I did, go back to the original statement. The value of that original crazy complex expression is just 19. And again, check your answer with a calculator or something. Okay. And I've got one more example where there are only numbers and no variables involved, but I'm still doing the same procedure every single time. Right. So in example 4, fraction, again, the main bar is here. The numerator is 1/6 plus 4/15. The denominator is 3/5 minus 1/2. Alright, so the denominators within this fraction are 6, which is 2 times 3, 15, which is 3 times 5, 5, which is just 5, and 2, which is just 2, right? Those are prime. Alright, so looking at all the factorizations of these denominators, the least common multiple of the denominators, or the least common denominator, or LCD, well, the factors that are showing up here are 2, 3, and 5. So I have 2 to some power times 3 to some power times 5 to some power. And the highest power on any of these is the first power, right? I'm not saying any power is higher than 1. So the LCD is 2 times 3 times 5, or 30. And again, you could have probably figured that out without writing all the factorizations, but I'm going to be doing this every single time. So I take the entire numerator, multiply it by 30, multiply each term by 30. Take the entire denominator, multiply each term by 30. And just don't forget you're distributing, you're multiplying every term by 30. A 6 times 30 is 5, plus 4/15 times 30 would be 8. And I'm assuming you know how to simplify and multiply fractions, or I'm going to kind of speed this up a bit. So the numerator is 5 plus 8, the numerator is 13. Denominator, 3/5 times 30 would be 18. Then we have minus, and then half of 30, half times 30 is 15. And 18 minus 15 is 3. And my final fraction here, 13 divided by 3, those don't have any common factor. So that's as simple as that gets, 13/3. Right? So, and again, go back to the original expression right before I did all the writing, and see if that expression has the same value as 13 divided by 3. And it should, if I did everything correctly, and I'm pretty certain I did. Okay. So now we're getting into examples with variables. Nothing changes. Nothing changes, okay? The numerator is c over d plus 1 over d. You have the main bar here. And the denominator is 1 over d minus d over c. So the denominators are already completely factored. There's d, 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 and c. So I'm hoping it's easy to see that the LCD is just c times d. Okay. Don't have to do too much with that. Then I take the numerator, multiply it by the LCD. Do the same with the denominator. Multiply it by the LCD, right, this CD. Now this time I'll actually write it out because it's the first example with variables. When I distribute here, we have c over d times cd plus 1 over d times cd. Right, that's the numerator. And I do the same in the denominator. Right? We have 1 over d times cd minus, and then d over c times cd. Right, and then, as in the first 4 examples, the whole reason I am multiplying the numerator and denominator by the LCD is so all those lesser denominators will cancel away. Right, we'll get a nice, simpler looking expression. Let's look at this. See, look at the numerator here. See this first term, the d's would cancel, and I'd be left with c times c, c squared, plus the second term. The d's cancel again, right? And I'm left with 1 times c, which is just c. So the numerator is c squared plus c. In the denominator, the first term, d's would cancel. I have 1 times c, which would just be c, minus And then the second term, the c's would cancel, and I'd have d times d, which is d squared. So there, I have a single fraction. Now let's see if it's simplified. Try factoring the numerator and the denominator. Now the numerator factors, right? There's a common factor of c. I pull that out, and I have c plus 1 left over as the other factor. And the denominator doesn't factor any further. So that's its own factor, right? C minus d squared. I'll put it in parentheses just to let you know that whole thing is its own factor. And I am not seeing a factor of c minus d squared in the numerator. Right? There's a factor of c plus 1, but there's no factor of c minus d squared. So this is as simple as it gets. Or you could have also multiplied things out and gotten this expression here, right? The c squared plus c in the numerator, c minus d squared in the denominator. Okay, now, as you've seen me do in previous videos, if you've been watching, I also like to go back through the problem and express some, state the values that I can't replace the variables with. So looking through the entire problem, if there's ever a denominator, that denominator can't be 0. So I'm seeing here there's a c in a denominator, right? So c can't be 0. I'm seeing a bunch of d's in denominators, so d can't be 0 either. And then there's this c minus d squared in the denominator at the very end. So c minus d squared can't be 0, or in other words, c can't be equal to d squared. So here are some conditions on the variables. All right, you can replace c and d with any numbers you want, but c and d can't be 0, and whatever c is, it can't be whatever d is squared. Meaning, like, if you replaced d with 1, you couldn't replace c with 1 as well. If you replaced d with the number 2, you couldn't replace c with 4. But you could replace c with 5. You could replace d with 2 and c with 5. That would be fine. So let's test it. All right, and here's how you test the expressions with variables. All right, so to test this, just to see if we believe that our final expression is correct, I'm going to look at, I'll look at the original expression value, and I'll look at the final expression's value. So I'll let c be, say 1. Yeah, I'll let c be 1 and d be 2, right? Because again, just so long as c and d aren't 0, and c is not equal to d squared, which is not happening here. These are allowable values. I go back to the original expression, again, ignoring the times cd, back to the way it originally looked. We have c over d, right? So 1/2 plus, and then 1 over d, which is another half, over 1 over d, another half, minus d over c, so minus 2 over 1. Well, the numerator is a half plus a half, that's 1. The denominator, half minus a half, a half minus 2 would be negative 3/2. So this ends up being negative 2/3, right? Remember, division is multiplying by the reciprocal. 1 divided by negative 3/2 would be 1 times negative 2/3. We get negative 2/3 for the original expression's value. And then when I look at the final expression, right, this in the box here, if I replace c with 1, you have 1 plus 1 is 2 in the numerator, and then 1 minus 4, right, d is 2, c is 1. 1 minus 2 squared, 1 minus 4 is negative 3 in the denominator, and these are the same value. Negative 2/3, 2 divided by negative 3 is the same as negative 2/3, right? They're the same value. And that should happen all the time. No matter what you replace c with and d with, again, as long as they're not 0 or c is not equal to d squared, as long as that's not happening, you're fine. And go ahead and check, is the value of the original expression, right, the way it originally looked, is that equal to the value of the final expression? And it should be every single time if you did things correctly. So it looks like I'm okay. I mean, again, this is just one pair of values for C and D. You can replace C and D with anything else, again, as long as these conditions aren't happening. And they should also give you equal values in the original statement and the final statement. All right. Now that'll be the only example I do that for. I'll leave it to you to test the rest of these. All right, so another one, again with some variables, m and n. All the denominators here are already factored. So I'm hoping it's obvious that the LCD here of all these denominators of the fractions within the fraction is just m times n. So then I multiply the entire numerator by m times n, multiply the denominator, right, the expression below the big bar, by m times n as well. And don't forget that you are distributing. There are multiple terms. Every single term in the numerator and every single term in the denominator gets multiplied by this m times n. Now 1 over m times mn, the m would cancel, leaving me with 1 times n, which would be n, plus m over n times mn. The n's would cancel, and I'd have m times m left, or just m squared. So the numerator is n plus m squared. And in the denominator, right, n over m times mn, the m's would cancel. I'd have n times n squared. Minus, and then 1 over n times mn, the n's would cancel. You have 1 times m left. That's just m. And neither of these factor any further. So this is as simple as that expression gets, right? Where you have a single numerator, a single denominator, and there are no common factors in the numerator or denominator. All right. Then again, I like to state some values that the variables cannot take. And anytime there's a denominator of 0, that's bad, right? You can't divide by 0, that's undefined. So back in the original expression, I'm seeing denominators of n, meaning that, n can't be 0. I'm also seeing denominators of just m, so m can't be 0 either. And then at the very end, I'm seeing a denominator of n squared minus m. So m, whatever value you choose for m, can't be your n squared, right? Because if they were equal, if m was 4 and n was 2, or if m was 9 and n was 3, stuff like that, you'd be dividing by 0 at the end, and that's not good. But for any other values, right, and you can test this, replace m and n with any other values, and the value of the original expression, right, before all the writing, should be exactly the same as the value of the expression at the end. And again, I leave that to you to test some values. Okay. All right, so again, pretty similar here. Again, there's the main bar. And numerator is 1 over p plus 1 over q. Denominator is 1 over p squared minus 1 over q squared. And all these little denominators are already factored completely, so I'm hoping you see that the LCD is p squared times q squared. And I'm not going to go into all the finding of LCDs, all the details every single time. I'm assuming you know how to find the least common multiple of some expressions, right, of denominators. So then I take the entire numerator, multiply by the LCD, p squared q squared. Take the entire denominator, multiply by the LCD, p squared q squared. And when I go through each term of the numerator, 1 over p times p squared q squared, one of the p's would cancel, and I'd be left with pq squared, right? P times q squared, plus, same thing for the next term, 1 over q times p squared q squared. Just one of the q's would cancel, and I'd be left with p squared times q to the first, p squared q. So there's the numerator divided by, and then when I multiply each term of the denominator by p squared q squared, I'd get, the p squareds cancel in the first term, leaving me with q squared minus, and then the q squared would cancel in the second term, leaving me with p squared. Alright, so here's a single fraction, which is what I want. I want a single fraction, one numerator, one denominator. It's not complex. There aren't fractions within fractions now. But now let's try, simplifying. Remember how to simplify. You got to factor the numerator completely and factor the denominator completely and see if there are any common factors, if any. On the numerator, both these terms have a p to the first and a q to the first at least, so I factor out pq. And if I factor out pq, you'll have q plus p left over as the other factor. Alright, and then the denominator is a difference of squares. That would factor to q minus p times q plus p. And I am seeing a common factor in the numerator and denominator. That's this q plus p factor. Now don't forget, when you cancel common factors, technically they're becoming the number 1. So just keep that in mind. So what I'm left with in the numerator is just p times q. And the only factor left in the denominator is q minus p. Now since it's the only factor left, there's no need to put parentheses around it. So p times q in the numerator and q minus p in the denominator, and there you go. That's as simple as that expression would get. And then as before, off to the side, I'm going to put some conditions on the variables. Like I'm seeing, again, throughout the problem, you see any factors in denominators at all, just make sure that those denominators are not 0. So I'm seeing p and p squared in denominators, right? So p can't be 0. I'm seeing q and q squared, and factors of q in denominator, so q can't be 0 either. And then we're seeing at the end, q squared minus p squared in the denominator, or as factors, when I factor it, q minus p, that can't be 0, so that means q can't be the same thing as p, right? Because q minus p would be 0 then. But also there was this factor before I canceled. There was this factor of q plus p in the denominator. That can't be 0 either. So q can't be the opposite of p either. So here are all the conditions on q and p. I can replace p and q with whatever numbers I want, as long as they're not 0, and as long as they're not the same number or opposite numbers. Right, so I couldn't replace p and q with both of them with 2, or I couldn't replace q with 3 and p with -3. Right? But I could replace q with 5 and p with 3, or q with 7 and p with 8, stuff like that. Just as long as they're not the same or not opposites, or neither one of them 0, you'd be fine. And then check it out, test it out. Go back to the original expression, the way it originally looked. Replace p and q with numbers that don't do bad stuff, right? That don't satisfy these conditions. And then test, is the original expression the same as this final expression? They should have the same value for any choice of p and q you make. Again, as long as p and q aren't 0 and p and q aren't the same and p and q are not opposites either. Alright? Alright. So same stuff, example 8. Same procedure every single time. So all these denominators, r, t, r squared, t squared, they're already factored. So I can tell you the LCD right now, it's just r squared, t squared, r squared times t squared. And then I take the entire numerator, right, everything above the main bar, the lawn bar, I'm going to multiply it by the LCD, r squared, t squared. Same thing for everything below. Multiply by the LCD, r squared, t squared. And that should cancel all those smaller denominators. Now up top, 2 over r times the LCD would be 2rt squared, right? One of the r's would cancel. Plus, and then 2 over t times r squared t squared would be 2r squared t. Right? One of the t's would cancel. There's the numerator. Multiplying each term of the denominator by the LCD gives me t squared minus r squared. Again, I'm hoping you can just see what's canceling. And then we try simplifying, right? Sure, this is great. It's a single fraction, one numerator, one denominator, awesome. But we can try to, simplify it even further. In the numerator, right, there's a GCF, greatest common factor, of 2RT. I can pull out 2 times r times t. Those factors, and then what's left would be t plus r. Then the denominator is a difference of squares, right? That would factor to t minus r times t plus r. And I am seeing a common factor, right? T plus r in the numerator and denominator, so cancel those. And what I'm left with in the numerator is 2 times r times t. And the only factor, the only expression left in the denominator is t minus r. And this fraction right here, right, this is as simple as that would get. And then once again, t couldn't be 0, because that would make that denominator 0 right up here. R couldn't be 0, because that would make these denominators 0. Right. And t can't be equal to r, because that would make this denominator 0, this factor. Also, t can't be the opposite of r. T and r can't be opposites, because this factor of t plus r that was in the denominator here before I canceled, that would be 0. So here are the conditions, very similar to example 7. Here are the conditions on the variables. You can replace t and r with any numbers you want, as long as none of these things are happening. And then check to see if and test it out for yourself. Replace r with 5 and t with 2, or r with 7 and t with -1, whatever. As long as they're valid replacements, and see if the original expression has the same value as the final expression. And it should, for whatever you choose for r and t. Right, again, as long as r and t are not 0 or the same number or opposite numbers, you should be fine. Okay. So the next example. Again, the same stuff. Big difference in this one though, right? Examples 4 through 8, or 5 through 8. The LCD was readily seen, right? Pretty easily seen. In example 9, the denominators, above the main bar and below the main bar are, they have more than one term. X plus 5, x minus 5, x squared minus 25. So we have x plus 5, that's just x plus 5. I'm listing these lesser denominators again here. So there's x plus 5, which, that's as factored as that gets. There's x minus 5. That's as factored as that gets. Then x squared minus 25, right, that factors to x minus 5 times x plus 5. And I'm hoping that you can see that's the LCD, right? The least common multiple of these would be, the factors that show up are x minus 5 and x plus 5, so the LCD is going to have x minus 5 to some power, x plus 5 to some power. And the highest power on each of these is the first power, right? The highest power you're seeing of x minus 5 is x minus 5 to the first, so that's in the LCD. The highest power on x plus 5 in any of these factorizations is x plus 5 to the first, so that's in the LCD. Alright, so what I'm going to do, and I'll be doing this with most examples from here on out, is I'm going to rewrite the expression I started with where all the denominators are factored. So in the numerator at the area above the main bar, we have 2 over x plus 5, and that denominator is already factored, divided by, and then 3 over x minus 5, right, that x minus 5 is already factored, plus, and then 1 over, and then factor the denominator, right, x minus 5 times x plus 5, right, so this is what I'm going to do to start each example from here on out, is I'm going to rewrite things so that all the denominators are factored. And I have stated the LCD. Right, so we're going to multiply the entire numerator. Now the numerator has just one fraction, just one term, this 2 over x plus 5. And I'm going to multiply it by the LCD, right, x minus 5 times x plus 5. The denominator has two terms, right? Remember, terms are separated by addition, right, or subtraction, but subtraction is just adding the opposite. There's this fraction, 3 over x minus 5, plus, and then a second term, right, 1 over x minus 5 times x plus 5. And again, I'm going to multiply the entire denominator by the LCD. And don't forget you're doing it to both terms down there. Now the whole reason for multiplying by the LCD, or multiplying the numerator and denominator by the LCD, is so all the lesser denominators get canceled. So the numerator, right, 2 over x plus 5 times the LCD, see how the x plus 5s would cancel? And I'd be left with the factors 2 and the quantity x minus 5, which we'll simplify in a little bit. Right. Over. And then I multiply the first term, right, the first fraction in the denominator by the LCD. The x minus 5s would cancel, and I'd be left with 3 times the quantity x plus 5. And then we have plus. And then when I multiply the second fraction in the denominator, the second term, by the LCD, both factors cancel, and I'm left with just 1. All right, and then we simplify the numerator and denominator. All right, the numerator would be 2x minus 10, which is factored to 2 times x minus 5. I might get back to that in a second. And the denominator, right, multiplying the 3 by x plus 5 here, give me 3x plus 15 plus 1 would be 3x plus 16, right, plus 15 plus 1. And this is going to be as simple as that gets, because again, the numerator is 2 times x minus 5. The denominator, 3x plus 16, that doesn't factor any further, so that would be its own factor. And I don't see any common factors in the numerator and denominator, so you could also write it this way in factored form if you wanted. Same thing. Right, they're both the same expression. Alright, and then, like I do with all the other examples with variables, I like to point out, what values you couldn't replace the variables with. So I'll do that at the end here. X cannot be replaced by, well, let's see, looking through the problem. The numerator, there's a denominator up here of x plus 5, so x can't be negative 5. That'll make that denominator 0. Here there's a denominator of x minus 5, right? So x can't be positive 5 either. And then there's x minus 5, x plus 5. I already covered those factors in that denominator. And then at the very end, there's a denominator of 3x plus 16. So x can't be negative 16 thirds either, because that would make that last denominator 0. Okay, so any other value is fine. You can replace x with anything except for negative 5, positive 5, and negative 16 thirds. So do that. Test it out. Replace x with numbers other than these three, and see if the value of the original expression is the same as the value of the final expression that I got. And they should be the same all the time. All right, and I leave that to you to test. Alright. So I'm doing the same stuff with the rest of the examples. Alright, so example 10. Same thing. I'm going to rewrite it so that all the denominators are factored completely. So we have 5 over, y minus 4 divided by 3 over y plus 4, and then still in the denominator here, plus 2 over, and then y squared minus 16 would factor to y minus 4 times y plus 4. Right, so I'm hoping that you see, looking at these denominators, that the LCD is just y minus 4 times y plus 4, right, or y squared minus 16. So I'm going to multiply the numerator, right, just this single fraction, by the LCD, and the denominator has a sum of 2 fractions, so each one is going to get multiplied by the LCD y minus 4 times y plus 4, right? And I'm going to be distributing that, and some things will cancel, right? The whole point of this is to cancel a lot of denominators. Alright, so the numerator, the y minus 4 would cancel. You're left with 5 times the quantity y plus 4. Alright, and so that's already in the numerator in a nice factored form, right, written as a product. So I'll leave it like that for now. The denominator, when I multiply the first fraction, the y plus 4's would cancel, and I'd be left with 3 times the factor y minus 4 in that first term. But then there's a second term, right, plus, and then the second one, both factors would cancel. I'm left with 2. Alright, so the numerator is written as a product. Great. The denominator is not a product. There's a sum, right? So I'll keep the numerator as its factored product here. The denominator, when I multiply the 3 and the y minus 4, there'd be 3y, minus 12 plus 2 would be minus 10, right? 3y minus 10. And that doesn't factor any further. So the numerator is totally factored, the denominator is totally factored now, right? It's just got the factor of 3y minus 10. And I'm not seeing a factor of 3y minus 10 in the numerator, so this is as simple as that fraction will get. Now, once again, you could also multiply things out. The numerator would be 5y plus 20, and the denominator 3y minus 10. This is totally valid as well. Alright, and then as I like to do, right, in every example where there are variables involved, state the conditions on the variables, right, the variables that you're not allowed to plug in. And then you could plug in anything else. Well, going back through looking for denominators here, well, y minus 4 is in a denominator, so y can't be positive 4. Y plus 4 is in a denominator, so y can't be negative 4. And then, not seeing anything. And then this 3y minus 10 is in a denominator at the end, so y can't be positive 10/3 either. Right? Because if y were any of these 3 values, you'd have some point during the problem where you have a denominator of 0, and you can't have a denominator of 0, right? You can't divide by 0. That is undefined. Alright, and then test it out. Go back to the original expression and replace y with a number other than these 3, and see if you get the same value in that expression as you do in the final one. And again, I leave it to you to test some values of y. Okay, 11. Sample 11. Nothing changes, no different, right? Like I said, I'm gonna rewrite the expression, but so that all the denominators, right, the denominators of these fractions within the fraction are factored. So we have in the numerator we have 5 over z minus 8 times z plus 8. Okay, plus 3 over z plus 8, right? Z plus 8 would be as factored as that gets. Then that's the numerator, and then in the denominator, I have 1 over z plus 8, and that's as factored as that denominator gets, plus 2 over z minus 8. And z minus 8 doesn't factor any further either. So I'm hoping it's obvious that the LCD, right, is just, z minus 8 times z plus 8. Alright, so I'm going to multiply both fractions. There are two terms, right, separated by plus. There are two terms in the numerator. I'm going to multiply both of those by the LCD, right, z minus 8 times z plus 8. And the same thing with the denominator, right? The denominator has two terms as well. And each of those fractions, each of those terms, will be multiplied by the LCD as well. Z minus 8 times z plus 8. Now in the numerator, when I distribute the LCD, I multiply both of these terms, both of these fractions by the LCD. In the first term, both z minus 8 and z plus 8 will cancel, leaving me with 5. And I have plus. And then in the second fraction, only the z plus 8 will cancel. Right, so those will be gone, leaving me with 3 and the quantity z minus 8. 3 times the quantity z minus 8. Right, and we'll simplify that in a second after multiplying the 3 by the z minus 8 and then adding 5. In the denominator, again, I'm distributing the LCD to both fractions. First fraction, z plus 8 would cancel, and I'd be left with 1 times z minus 8, which would just be z minus 8. And we have plus. Then the second fraction of the denominator, the z minus 8s would cancel, and I'd be left with 2 and z plus 8. 2 times the quantity z plus 8. Alright, now let me actually simplify here. The numerator, after multiplying 3 and z minus 8, would be 3z minus 24 plus 5. That'd be minus 19. So 3z minus 19 in the numerator. And in the denominator, after multiplying the 2 and the z plus 8, we have 2z plus another z. That'd be 3z. And then plus 16 minus 8. Plus 16 minus 8 would be plus 8. So the denominator is 3z plus 8 after simplifying. Alright, now I have what I want. I have a single fraction, one numerator, one denominator. I'd like to see if we can simplify this even further, but we can't. The numerator is already totally factored, can't be factored any further. Same thing with the denominator. And don't cancel the 3z's. That'd be bad canceling. You can't cancel terms. You can only cancel factors, parts of products. Right? So this is as simple as it gets. Numerator 3z minus 19, denominator 3z plus 8. And then just as with all the other examples, I'm going to list the values I can't replace the variables with, right? So what can I not replace z with? Well, can't replace z with negative 8 because that makes these denominators 0. Right? Anywhere there'd be a denominator of 0, that's bad. Right? Z can't be positive 8 either, because that denominator would be 0. And then there's one final denominator at the end, 3z plus 8. That can't be 0, so z can't be negative 8/3 either. But for any other value of z, we can plug it in. Right? So plug in any other value of z to the original expression and the final expression and see that you'll get the same value for both, no matter what you plug in for z. Again, as long as it's not negative 8, positive 8, or negative 8/3, you're fine. So moving along. Now these next all the examples are the same. I'm doing the same steps. So again, two fractions being added in the numerator, two fractions being added in the denominator, just like example 11. So once again, first I'm going to write it out so that all the denominators are factored. We have 3 over s plus 6, and s plus 6 is already completely factored, plus 5 over, and then s minus 6 is completely factored, divided by, right, the main fraction bar. Then in the denominator we have 1 over, s squared minus 36 would factor to s minus 6 times s plus 6 plus, and then 4 over s plus 6, right? 4 over, and then s plus 6 is totally factored. Alright, so the LCD, I'm hoping again is obvious. The LCD, looking at all these denominators, factorizations, is s minus 6 times s plus 6. Alright, so I'm going to multiply the entire numerator, right, both terms, by the LCD, s minus 6 times s plus 6, and the entire denominator as well, by the LCD, s minus 6 times s plus 6. Alright, now we have to distribute, right? There are two fractions in the numerator. Each one gets multiplied by the LCD. In the first fraction, right, the s plus 6's would cancel, leaving me with 3 and s minus 6. 3 in the quantity s minus 6 for the first term. Plus, and then the second fraction multiplied by the LCD, the s minus 6's would cancel, leaving me with 5 and the quantity s plus 6. And we'll simplify that in a second. Then doing the same in the denominator, right, multiplying both fractions, each term, by the LCD. In the first term, both s minus 6 and s plus 6 would cancel, leaving me with 1 plus. Then in the second fraction, just the s plus 6's would cancel, leaving me with 4 and the quantity s minus 6. All right, now multiplying in the numerator here, multiplying the 3 and the s minus 6 and the 5 and the s plus 6 and combining like terms, I'd have 3s plus 5s would give me 8s, then minus 18 plus 30. So negative 18 plus 30, 30 minus 18, that'd be positive 12. Okay, so the numerator is 8s plus 12, which can be factored further, right? There is a greatest common factor of those two terms. We'll get to that in a second. And then the denominator, after multiplying the 4 and the s minus 6, we'd have 4s. Then there's a minus 24 plus a 1. Minus 24 plus 1, that'd be minus 23. Now, you could factor the numerator more by factoring out a 4. That'd be 4 times 2s plus 3. And the denominator, though, right, 4s minus 23 doesn't factor any further. That would just stay 4s minus 23. And there's no factor of 4s minus 23 in the numerator. So this is as simple as it gets, or you could also write it in factored form, right? Both of these are equally valid. All right, and then as with the other with all the other problems, I'm going to list off to the side the values that the variable s can't take. All right, and just remember, you don't want any denominators to be 0, because that'll be dividing by 0, which is undefined. Right? That's bad. So looking at all the denominators here, I'm seeing s can't be negative 6, it can't be positive 6. And all the denominators that are showing up here, the last denominator, right, 4s minus 23, that can't be 0 either. So s can't be positive 23/4 either. Right, so it can't be negative 6, can't be positive 6. Also can't be 23/4, because I never want to divide by 0. All right, and then test it out. Go back to the original expression, replace s with any value that's not one of these three, and you'll see that the value of the original expression will be the same as the value of the final expression, right, with that same value of s. That should be happening, right, as long as you did everything correctly. Right, I leave it to you to test some values of s. Alright, example 13, again, nothing changing. Same stuff. So I'm going to rewrite the complex fraction so that all the denominators are factored completely. So in the numerator, right above the main bar, is just one fraction. That'd be 4 over a squared minus 2a minus 15 factors to a minus 5 times a plus 3. Alright, so there's the numerator. And the denominator has two terms, right? Sum of two fractions, and that's 1 over. Now, a minus 5 is already completely factored, so that's the only factor of that denominator, a minus 5. Plus 2 over, and a plus 3 is as factored as that denominator is going to get, so a plus 3. So once again, I'm hoping that it's obvious what the LCD is here. It's just a minus 5 times a plus 3. And that's what I'm going to multiply the numerator and denominator by. So this numerator, right, this single fraction up here above the main bar, multiply that by the LCD, a minus 5 times a plus 3. The denominator has two terms, right? So I'm going to again multiply both of these fractions, both terms, by the LCD, a minus 5 times a plus 3. All right. The numerator, both factors will cancel, leaving me with 4 over, and then distributing the LCD to both fractions in the denominator leaves me with a plus 3 for the first term, plus, and then 2 times the quantity a minus 5 for the second term. Right, the a plus 3's would cancel. And then totally simplifying the numerator and denominator, we have 4 in the numerator, and then distributing the 2 here to the a minus 5, we'd have 2a plus 1a is 3a. Then 3 plus negative 10 would be minus 7. And looking at those that numerator of 4 and denominator of 3a minus 7, yeah, you could factor 4 to 2 times 2, but I'm not seeing any factors of 2 in the denominator. Right? The only factor of the denominator is 3a minus 7. So this is as simple as that expression is going to get. And once again, at the end, I like to point out the values that I can't replace the variables with, right? So looking through the denominators here at all the factors that show up in denominators, a minus 5, a plus 3. So a can't be positive 5, a can't be negative 3. And then at the very end, you have a denominator of 3a minus 7. That can't be 0 either, so a can't be positive 7/3. And so here are the values you can't replace a with. And then go back and test it out, try out some values of a, that aren't one of these three. And see if the value of the initial expression is the same as the value of my final expression. And they should be, right, for any choice of a, as long as it's not 5, negative 3, or 7/3. Right, example 14, very similar, right? And I'm doing the same steps every time. Right. So again, I'm going to rewrite this complex fraction so that all the denominators are factored completely. So the numerator, right, everything above the main bar, has 5 over and b squared minus 6b minus 27. That would factor to b minus 9 times b plus 3. Alright, so there's the numerator. Denominator has the sum of two terms, right, two fractions. And the denominators of these fractions are already factored, right? 3 over b minus 9 plus 1 over, and b plus 3 is as factored as that's going to get. Right? So again, I hope it's obvious what the LCD is after factoring these denominators completely. The least common denominator is, b minus 9 times b plus 3. And so now, I multiply the entire numerator, right, that one fraction up here by the LCD, b minus 9 times b plus 3. And the denominator, right, under the main bar, the denominator has two terms, and each of those will get multiplied by the LCD as well. So in the numerator, I'm left with just the number 5, right, because both b minus 9 and b plus 3 would cancel. And then you have you're multiplying each fraction in the denominator by the LCD. In the first term, you'd have 3 times the quantity b plus 3 left over, right, because the b minus 9s would cancel, plus, and then the second term, the b plus 3s would cancel, leaving me with b minus 9. Right, just 1 times b minus 9, or just, b minus 9. Numerator is just 5 when we simplify. And the denominator, right, after distributing the 3 and the 1, you'd have 3b plus 1b is 4b, and then 9 plus negative 9, that's 0. So yeah, we just end up with 5 in the numerator and 4b in the denominator, and that is as simple as that gets, right? The numerator and denominator have no common factor. 5 divided by 4b. Alright, and then just like all the others, right, I'm just going to state off to the side here the values I can't replace b with, right? The numbers that would make you divide by 0 or give you denominators of 0 somewhere. So I'm seeing, b minus 9 in a denominator, b plus 3 in a denominator. So b can't be positive 9, it can't be negative 3. And then looking at all the denominators throughout this problem, the only other denominator I haven't addressed is this 4b down here. There's a factor of b in the denominator, so b can't be 0 either. So b cannot be replaced with 9, negative 3, or 0, because that'll give me a denominator of 0 somewhere throughout this problem, and you can't have that, right? You can't divide by 0. But for any other value of b, the value of the initial expression should be equal to the value of this final expression. And again, I leave it to you to test out some choices of b. Okay, example 15, not doing anything different. I'm going to rewrite it so that all the denominators of the fractions within the fraction are factored. So this is 5 over, c plus 2 is as factored as that gets, minus, and then 3 over, and c plus 7 is as factored as that denominator will get. And then we have divided by, and then there's one fraction, one term in the denominator, and that's 5c over, and then I factor that denominator, c squared plus 9c plus 14 would be c plus 2 times c plus 7. So once again, as in the previous several examples, I'm hoping the LCD is easy to determine after factoring all these denominators, and it would just be c plus 2 times c plus 7. And I'm going to now multiply, right, the entire numerator, which has 2 terms, right? There are 2 fractions being subtracted here. Multiply the entire numerator by the LCD, the c plus 2 times c plus 7. And there's only the one fraction in the denominator that is being multiplied by the LCD, c plus 2 times c plus 7. Okay, so distributing the LCD to the 2 terms in the numerator give me the following. First term, the c plus 2's would cancel. I'd have 5 times c plus 7. 5 times the quantity c plus 7. Then we have minus. In the second fraction, c plus 7 would cancel. I'd have 3 times the quantity c plus 2. Now don't forget the minus sign there, right? Technically, this is plus negative 3 times c plus 2. So don't forget, when we distribute here, we'll be distributing negative 3, not positive 3. Alright, then in the denominator, both c plus 2 and c plus 7 would cancel, leaving me with 5 times c. Alright, so now I distribute the 5 here to the c plus 7. Distribute negative 3, right? Don't forget you're doing the whole negative 3 to the c plus 2 and then combining like terms. We'd have 5c minus 3c would be 2c. And then the constants, you have 35 minus 6, which would be positive 29. Right, 35 minus 6. So the numerator is 2c plus 29, and the denominator is simply 5c. And again, single fraction, one numerator, one denominator, great. The numerator can't factor any further, and I don't see any factors of 2c plus 29 in the denominator, so this is it. This is as simple as that fraction will get. Alright, and then I'm going to state all the values that c cannot be replaced with. Well, I'm seeing a c plus 2 in a denominator, a c plus 7 in a denominator, so c can't be negative 2, can't be negative 7, right, because those will make me have denominators of 0, divide by 0 somewhere. That's bad. And then looking through here at the very end, I'm seeing a factor of c in the last denominator, so c can't be 0 either, because that would make that last denominator 0, and that's also bad. But for any other value of c, right, the value of the initial expression should be exactly the same as the value of this last expression, right? And I leave it to you to test different values of c if you want. Okay. Example 16. Right, again, nothing is changing. Doing the same procedure every single time. So I'm rewriting the complex fractions so all the little denominators are completely factored. So up here in the numerator you have 6 over, now d minus 4 doesn't factor any further, right? So that would be the only factor of it, d minus 4. Minus, then 2 over, and d plus 7 would be the only factor of d plus 7. Then the denominator has the fraction 2d over, and then d squared plus 3d minus 28. That would factor to d minus 4 times d plus 7. So once again, I'm hoping it's obvious what the LCD is here. After looking at all these factored denominators, it would just be d minus 4 times d plus 7. All right. And I'm multiplying the entire numerator. Right, both terms, right? They're separated by plus a minus. It's a difference. If it's a sum or a difference, you're going to have to multiply. There's multiple terms. We're going to multiply both those terms by the LCD and do the same thing to the denominator fraction. Now there's only one fraction in the denominator. I'm going to multiply that by the LCD as well. Alright, so when I distribute the LCD to the two fractions, the two terms in the numerator, be left with the following, right? In the first term, d minus 4s would cancel. And I'd have 6 times the quantity d plus 7. Then we have minus 2 times the quantity d minus 4, right? Because in the next fraction, d plus 7 would cancel. I'd be left with the quantity d minus 4. And don't forget, we're going to be distributing the negative 2 here, not just the positive 2. And then the denominator would just be 2d. The d minus 4 and the d plus 7 would both cancel. Alright, so distributing the 6 here, distributing the negative 2 here, and combining like terms gives me a simplified numerator. We'd have 6d minus 2d, that'd be 4d, and then plus 42 plus 8, right? Negative 2 times negative 4. So 42 plus 8, positive 50. So the numerator is 4d plus 50. The denominator is 2 times d. Now, this is a single fraction like I want, one numerator, one denominator. But I do see it can be factored, it can be simplified further. There is a common factor in the numerator and denominator. right, if you factor the numerator, right, there is a greatest common factor of these two terms of 2, right? I can pull 2 out, and then you'd have 2d plus 25 as the other factor. And then the factors in the denominator are 2 and d. So the common factor here in the numerator and denominator is 2. And when I cancel those, I'm left with 2d plus 25 in the numerator and just d in the denominator. And that's it. That is as simple as this gets. Right? The numerator and denominator have no common factors. And at the bottom here, I'll list the values that d cannot be replaced with. All right, so d cannot be equal to positive 4, because that'll make this denominator 0. Negative 7 will make this denominator 0, and this denominator 0. And then also 0. 0 would make this denominator 0 at the end. So d cannot be replaced by positive 4, it can't be replaced by negative 7, and it can't be replaced by 0. All right, but anything else would be fine. All right, replace d with any other number, and the value of the original expression will be equal to the value of this last expression, again, if you did everything correctly. And I leave it to you to test some values of d that you want. All right. Example 17. Now, this first term of the numerator is just 2. It has no denominator. But remember, if something has no denominator, technically it has a denominator of 1. So this is 2 over 1, which you can write if you want. So 1, and then plus 1 over p minus 3. P minus 3 is already completely factored. And then in the denominator of the complex fraction, right underneath the big bar, is 5 over p minus 3. That has a denominator of p minus 3. I'm hoping it's obvious, right? The only denominator really showing up in here is p minus 3. So that's the LCD. So I take, multiply both terms of the numerator, right? There's a sum. Multiply both of those by the quantity p minus 3, the LCD. And there's only one fraction in the denominator, right? So I multiply that also by p minus 3. Now when I distribute this in the numerator, right, multiply both these terms in the numerator by p minus 3, I get, just 2 times the quantity p minus 3 for the first term. Then we have plus, and then the second term, the p minus 3's would cancel, and I'm left with 1. And we will simplify that in a second. In the denominator, the p minus 3's would cancel, I'm left with 5. Then distributing the 2 here, we have 2p minus 6 plus 1 would be 2p minus 5 in the numerator. And I have 5 in the denominator, and the numerator has only the factor of 2p minus 5, right? It can't be factored any further. And the denominator has only the factor of 5, and I'm not seeing a factor. Don't cancel the 5's. That is not times 5, right? It's minus 5, so that's not a factor. The only factor of the numerator is 2p minus 5, and I am not seeing a factor of 2p minus 5 in the denominator, so nothing cancels here. That is as simple as that fraction will get. 2p minus 5 divided by 5. And then once again, I'm stating the values that I can't replace p with. Well, the only denominators that show up here are, p minus 3, 1, and 5. The only value of p that I'll have a denominator be 0 is positive 3. Right? So that's the only value that I can't use for p. But you could replace p with anything else, anything other than 3, and the value of the original expression before all the writing. The value of the original expression should be exactly the same as the value of the final expression here. So for instance, if you replaced p with 0, both expressions would have a value of negative 1. Right? If you replaced p with 5, both expressions would have a value of positive 1 in the end. Right? And you can test it out. Right? Test it out. Replace p with some value other than 3 and make sure the value of the original expression is the same as the value of the final one. And I leave that to you to test, some values of p. Alright, just a few more. And again, I'm doing the same thing every time, the same steps. This example, example 18, the LCD I'm hoping is obviously n minus 2. It's the only denominator showing up here. So I multiply the numerator, right, everything above the big bar. This is only that one fraction by the LCD, by the quantity n minus 2. And there are 2 terms in the denominator, right, and I'll multiply both of those by the LCD n minus 2. Alright, so in the numerator, the n minus 2's cancel. I'm left with n. In the denominator, right, we're distributing this to both terms down here. So I have 3 times the quantity n minus 2 plus 5, right, because the n minus 2's would cancel there. I'm left with 5. Then after distributing the 3 to the n minus 2 there, and simplifying, we have n in the numerator still, and then 3n minus 6 plus 5. That'd be 3n minus 1. And this is as simple as this gets, right? The numerator and denominator are already factored completely, and you can see that they don't share any common factors. Once again, please don't do the bad canceling. Too many people will cancel the n's just because they see them in the numerator and denominator, but this is not a factor of n, all right? This is not 3n times negative 1. If it were, you could cancel the n. It's 3n minus 1. A difference, not a product. All right, and then n cannot be replaced by 2, all right, because I'll make these denominators 0. And at the very end, n can't be replaced by 1/3, because that would make the last denominator 0 as well. All right, but any other value is fine. So replace n with some number other than 2 or 1/3, and see that the original expression, right before all the writing, has the same value as the final expression, and they should if I did everything correctly. All right, example 19, same thing. Now this is a little trickier, because notice that the denominators that are showing up here are m plus 5 and m minus 5 and 1. Right? This is like 4/1. But all the denominators are already factored, so we can state the LCD very quickly. It would be m plus 5 times m minus 5. All right, that's the LCD. M squared minus 25 if you want to multiply it out. So I take the numerator, right, this single fraction multiplied by the LCD, m plus 5 times m minus 5. And same thing with the denominator. Now the denominator has 2 terms. So each of these will be multiplied by the LCD of m plus 5 times m minus 5. All right, now the numerator, the m plus 5's would cancel, and I'd be left with m times the quantity m minus 5. And then I'm distributing the LCD to both terms, both fractions in the denominator. Now nothing would cancel with this first one. The first one is a denominator of 1. So I have 4 times the whole LCD times the quantity m plus 5 times the quantity m minus 5. All right. Plus, and then the second fraction, the m minus 5's would cancel, and I have just 1 times m, just m plus 5, right? You could put it in parentheses and say times 1, but I'll leave it like that. All right, so now we can simplify. Now the numerator is already a nice factored expression, right? It's already a nice product. Now something I'm noticing that you might not, but if you do, great. If not, you can multiply this all out, simplify it, and then factor. But one thing I'm noticing in this term and this term is that they both have the factor of m plus 5. So I'm going to factor that out right now. So the numerator is m times m minus 5. And then when I pull this common factor of m plus 5 out, what I'm left with, again, imagine removing that. I'm just pulling it out, m plus 5. Then you'd have, 4 times m minus 5 plus 1. Well, that would be 4m minus 20 plus 1. That'd be 4m minus 19 as the other factor. All right. Okay, hopefully that made some sense. Hopefully I'm assuming again you know how to factor polynomials. And then looking at these two, right, the numerator's completely factored, the denominator's completely factored. I am not seeing any common factors. So this is as simple as that fraction gets. Now you could also, multiply out the numerator, make it m squared minus 5m, and then multiply out the denominator. That'd be 4m squared plus 20m minus 19m would be plus m, and then 5 times 19 is 95, but negative, right? So minus 95, right? You could this is also equally valid, right? And just like all the other examples with variables, I'm going to make a little statement on the bottom here, and just list all the values I can't replace m with, right? Values that make some denominator 0 somewhere, right? And you can't have denominators of 0. So negative 5 would make that denominator 0, positive 5 would make that denominator 0. So I can't use negative 5, can't use positive 5 for m. And then at the very end, you see I had m plus 5, so negative 5, I already said I can't use that. But then there's this other factor in the denominator at the end, 4m minus 19. That can't be 0 either, because then the whole denominator would be 0. So m can't also be 19/4. But I could replace m with any other value. And go ahead and try it out, right? Replace m with any other value but these three, and the original expression should have the same exact value as this last expression. Right, and I leave it to you to test certain values of m that you want. All right, and the very last example, example 20, is same steps. I'm doing the same steps every time, finding the LCD, multiplying the numerator and denominator by the LCD, and simplifying. Well, again, I hope it's obvious. The denominators here are 1, q minus 2, and q plus 2. They're already factored, so the LCD is very easily stated. It's just q minus 2 times q plus 2. That would be the least common denominator. Alright, then I multiply the numerator and denominator of this expression by the LCD. Now the numerator has two terms, so I'm going to be distributing the LCD. So I'm multiplying by q minus 2 times q plus 2. And the denominator has just this single fraction, but still multiply the numerator by the LCD, so I also have to multiply the denominator by the LCD, q minus 2 times q plus 2. Alright, now the numerator, again, I'm distributing because there are two terms up here. So that'd be 7 times the LCD, nothing canceling, right? 7 times q minus 2 times q plus 2, plus, and then the second term, the q minus 2's would cancel, and I'd have 2 times the quantity q plus 2. Alright. And we'll simplify that, factor it in a second. And then in the denominator, this q plus 2 would cancel, leaving me with just q minus 2, right? Or 1 times q minus 2, but that's just q minus 2. And you can put parentheses if you want, because it's already completely factored. Q minus 2 would be its own factor. Okay. Alright, so in the numerator, now you can multiply this out, multiply this, and combine like terms and all that. But I eventually want to try simplifying the fraction. So one thing I'm noticing is that this first product, this first term, and the second product, or the second term, they both have a factor of q plus 2. This quantity q plus 2 in common. So I will pull that out. I'd have q plus 2 factored out. And when I do that, and again, just kind of imagine they're pulled out. Imagine they're pulled out, pull them out, pull them out, pull them out. What would be left over would be this 7 times q minus 2, which is 7q minus 14, and then plus 2. 7q minus 14 plus 2 would be 7q minus 12. So when I remove that factor, that common factor of q plus 2, there's one factor, and then the remaining factor, the remaining stuff, would be 7q minus 12. Hopefully that made sense. Again, you could have just did all the long way. You could have multiplied that all out, multiplied that out, combined like terms, and then factored, and you would have got these two factors. I promise you that. All right, and then the denominator is just q minus 2. All right, that's as simple as that gets. Now the denominator, again, this is its own factor. That's as factored as it gets. So you can put parentheses if you want. Nothing change. No, that doesn't harm anything. And then look, the numerator is now a product. The numerator is now factored completely. The denominator is factored completely. There are no common factors in the numerator and denominator. So here we go. This is as simple as that fraction is going to get. Of course, you could also, multiply them out. The numerator would be 7q squared. And you got plus 14q minus 12q, so plus 2q. And then minus 24. Okay. And the denominator is simply q minus 2. All right, and this is equally valid, right, an equally valid answer. So you can leave things factored or actually multiply them out, same thing. And then once again, as in all the other examples, I am going to state the values I can't replace q with. Right? Q cannot be positive 2, right, because it'll make that denominator 0. Can't be negative 2, because it'll make that denominator 0. Right? You never want a denominator of 0. And that seems to be it. All right, looking throughout the entire problem, the only values that make any of the denominators 0 are 2 and negative 2. So you can replace q with any other value you wish. Right? 0, 1, 5, 100, whatever you want. And the value of the original expression should be exactly the same as the value of the final expression. And I leave it to you to test, to plug in different values of q and see if the value of that original expression is the same as the value of the expression we ended up with, the simplified expression. And they should be, right? If you did everything correctly, those values should be the same. Right. So again, to refresh the steps, each time I was doing this, we found the least common denominator of all the fractions within the fraction, within the rational expression, multiplied the numerator and denominator by the LCD, and then simplified afterwards, of course. And I wanted to end up with a fraction, one numerator, one denominator, where the numerator and denominator didn't have any common factors. Okay. All right, great. And hopefully, watching me go through these 20 examples helps you out when you're working on similar problems on your own. And one other thing too, I mentioned that this is a second method to simplifying complex fractions, complex rational expressions. You could use this method with the LCD, or the first method in a previous video I put out on writing complex fractions as a division problem. Either way, you end up with the same results. All right, so you decide which method you like better and use that one. And thank you very much for watching.